Abstract factory is a creational design pattern which solves the problem of creating entire product families without specifying their concrete classes. Following our furniture factory example, we first create a default factory with our flagship products such as chairs and tables. Once we have these standard products from our furniture offering, we can then, drawing on the established production line, quickly create new types of furniture based on existing machines and designs. In our case, this will involve opening a new production line for modern furniture and a separate factory for vintage furniture. This is the essence of this design model. Let's begin our Java example by writing a chair template. This interface, for simplicity's sake, contains only one method for creating this element. Here we can define a whole list of methods for this element such as seating, cushion attachment, etc. However, it's important to remember that these methods must be common to every chair type. Once we've created a list of possible actions, let's move on to implementing these methods. In this case, we have a specific type, a vintage chair. Here we define all methods specific to this particular chair. This means that we can engrave antique patterns and attach floral upholstery while creating the chair. Next, we create a locker similarly. It might contain similar or different methods specific to lockers, such as opening doors or sliding drawers. In this case, for a variety, we'll create a modern locker type. Let's assume the create method includes all the steps needed to create a modern IKEA-style cabinet, such as creating any aluminum door frame, gluing a mirror, and creating self-closing hinges. Once we have a complete set of furniture for a given type, we next need to define any abstract factory that can produce the entire set regardless of type. We need to define a complete set of methods for producing individual items from this set. It's important to remember that these methods should return any interface, not any specific class, so we can freely use it to create any factory producing any type of furniture. Here we implement this interface for our modern furniture factory. Each creation method in this case should return a specific type from the modern furniture family. Of course, these methods can contain specific steps for creating a given class type, such as creating chair legs, a backrest, etc., which will be passed to the class constructor. Once we have this defined, we can move on to using this class in client code. In this case, we'll create a universal class that handles order from any type of furniture from the customer. By passing any abstract class in the constructor parameter, we decouple orders from a specific furniture type. Furthermore, by defining common methods for each element, we can easily invoke them to fulfill the order. In this case, each order applies to the entire furniture set, including assembly, etc. The client code that accepts order for a furniture set creates the appropriate factory based on a command line argument. This specific factory is then passed to the order constructor. The steps required to fulfill that order are then executed, although this is magically delegated to our factory, which will then handle the production of the specific furniture. This is the beauty of this design pattern. Here we have a little overview of just presented connotations between the classes and their responsibilities. Subscribe for more videos like this one.